In northwestern New Mexico's San Juan Basin, the Kirtland Formation records a broad coastal plain of rivers and floodplains during the late Campanian. It was named Kirtland Shale in 1916 by Bauer for outcrops near the Kirtland Post Office, and later formalized as the Kirtland Formation. It overlies the coal-rich Fruitland Formation and is divided into the Hunter Wash, Farmington Sandstone, and Denazin members. Key volcanic ashes in the Denazin member date 72 million years ago, anchoring the upper Kirtland in time. Plant fossils including palms, together with abundant crocodilians, indicate a warm, humid to subhumid subtropical floodplain. This landscape supported a rich fauna, among them the tube-crested hadrosaur Parasaurolophus tubasin, the ankylosaurids Nodocephalosaurus and Ziapelta, and the deep-snout tyrannosauroid Bistahieversor. Together these assemblages define the Kirtlandian land vertebrate age, a biochronologic interval between the Judithian and Edmontonian. Classic outcrops in the Denazin wilderness have yielded the Bisti beast, and the section steps upward into the Ojo-Alamo Formation, with the Naashoibito interval now commonly assigned there rather than to the Kirtland. In those lowland waterways, the bowfin relative Melvius stands out. Its Kirtland species is widely treated as diagnostic of the Kirtlandian fauna in the San Juan Basin. The genus was erected from Melvius thomasii from the Hell Creek Formation, and a second species from New Mexico, Melvius chauliatus, was named in 1989 from Kirtland rocks. Recently, an articulated skull roof and brain case from the Kirtland Formation sharpened its cranial anatomy and clarified its placement among Vitolamian ammiids. Among soft-shell turtles, Plastomenus represents the Plastomenine lineage within Trionychidae, spanning the late Cretaceous into the Eocene, with Plastomenus thomasii as the last survivor. Micro-CT work has mapped its head in fine detail, showing an unusually long, spatulate mandibular symphysis and other cranial traits rare among softshells. Its record links fluvial landscapes. Specimens such as Plastomenus joycei come from riverine floodplain deposits of the Denver Formation, and its tangled taxonomy is being revised, with names once placed in Plastomenus reinterpreted within Trionychidae. Basilemys was a heavy, tortoise-like land turtle that browsed tough plants on the Campanian floodplain. Shell and skull studies point to a chiefly terrestrial lifestyle rather than a riverine one. The San Juan Basin record includes Basilemys nobilis, named from a nearly complete shell and plastron collected at a Hunter Wash horizon, a reassessment that also cleared up older, doubtful names. In life you'd see a broad, about 1 meter dome armored in coarse pits and triangular tubercles, driven by stout columnar limbs and a strong beak for shearing vegetation. Broad snout and medium-bodied, Leidyosuchus hugged oxbows and slow channels as a semi-aquatic ambush hunter, its skull proportions and armor recalling modern caimans. San Juan Basin fossils, teeth, osteoderms and fragments, have been referred to Leidyosuchus in the Denazin member, and earlier faunal lists even named Leidyosuchus canadensis among the local crocodilians. Taxonomically, most species once parked in Leidyosuchus were reassigned by Brochu to Boryelosuchus, so these basin records are treated cautiously until diagnostic skulls turn up. With robust jaws and bulbous rear teeth, Bachychampsa is often cast as a hard prey specialist that could crack shelly animals such as small turtles, though tooth shape by itself is not a reliable diet test. The San Juan Basin yielded the first clearly diagnostic skull pieces of the genus here, building on Gilmore's earlier reports of isolated teeth and prompting a re-evaluation of the local name Bachychampsa montana. Picture a compact, short-snout alligatoroid whose dentition grades from narrow cones at the front to globodont crushers at the back, a heterodont pattern documented by detailed skull studies from Hell Creek and echoed in the Kirtland material. Slim-boned and long-winged, Navajodactylus was a medium pterodactyloid with an estimated wingspan of at least 3.5 meters, diagnosed by its unusually extensive extensor tendon process on the first wing phalanx. The holotype and a referred ulna came from Denver's blowout in the Ahshislepelta Badlands and were published by Robert Sullivan and Denver Fowler in 2011. Dinosaur park phalanges once tied to this genus were later reassessed with the naming of Cryodracon. If it shared as darkid habits, imagine a ground foraging flyer stalking small vertebrates and large invertebrates across open floodplains, an ecology supported for as darkids in functional studies, yet its family assignment remains tentative. Armored and low-slung, Ahshislepelta likely foraged on low vegetation in the leafy lowlands, relying on a dense pavement of bony skin plates for protection. Discovered in 2005 at the Ahshislepelta Wilderness and collected through 2009, it was named by Burns and Sullivan in 2011, a partial skeleton with shoulder girdle, forelimb bones, vertebrae and many osteoderms. In life it would have been a relatively small ankylosaurid with a squat build and pitted, pebble-textured armor. A distinctive overhanging shoulder process helps diagnose the taxon. Thick-set and deeply plated, Ziapelta wore a skull carpeted in irregular caputegulae with a large triangular median nasal boss and forward-flexed squamosal horns, and its neck was girdled by tall, co-ossified osteoderms. In 2011 an expedition recovered the holotype, a complete skull with associated cervical half-rings, from Hunter Wash in the Denazin member. Arbor and colleagues named it in 2014 and later referred a complete first half-ring from the older Hunter Wash member. Ecologically it reads as a low-browsing, defense-biased herbivore, and cladistic work aligns it with northern ankylosaurians such as Euoplocephalus rather than the local Nodocephalosaurus, underscoring Campanian ankylosaurid diversity. Under a mosaic of bulbous, conical caputegulae, including a ridge-like L'Oreal boss and a forward-peaked quadratojugal horn, Nodocephalosaurus would have cut a compact, tank-like profile, its cranial pattern recalling Asian ankylosaurids and the Utah form Echinocephalus. The species is based on a partial skull described by Robert Sullivan in 1999, with later papers proposing referrals of isolated armor and tail club elements to the taxon. Functionally, it most plausibly occupied a low-browsing herbivore niche on floodplains, with wide beaks for bulk cropping and heavy armor for passive defense, patterns supported by ecomorphological and microwear studies of ankylosaurids. Small, two-legged and dome-headed, Stegoceras likely filled the role of a nimble, mid-sized herbivore on Campanian floodplains. Frontoparietal domes from the upper Fruitland, lower Hunter Wash interval were named Stegoceras in 2011, though later work showed the specimen is immature and left its distinctness unresolved. In life, imagine a goat-length biped with a short snout, large eye sockets, and a thick, smooth skull dome bordered by small knobs along the parietosquamosal shelf. What that dome was for remains debated. Histology questioned habitual head ramming, whereas CT-based modeling and the high rate of cranial injuries in Pachycephalosaurs point to at least occasional head or flank butting. Compact and high-domed, Sphaerotholus carried a rounded skull roof ringed with small bony nodes, with the type species showing a parietosquamosal bar that thins laterally and is bordered by a single row of nodes. Williamson and Carr erected the genus in 2002 from an incomplete skull, and later geometric morphometric work refined the separation of other species such as Sphaerotholus buchholtzi and Goodwini. Ecologically it fits a small, quick herbivore that engaged in display and contests using that thick dome. Pachycephalosaur skulls show a striking injury rate consistent with head butting. As a chasmosaurine herbivore, Bisticeratops cropped tough floodplain plants with a parrot-like beak and deep-tooth batteries, displaying long supraorbital horns and a broad frill that likely served both signaling and defense. Its mostly complete holotype skull, collected in 1975 from the Upper Farmington member at Bisti and named in 2022, shows distinctive cranial traits and preserves multiple tyrannosaurid bite marks on the face and frill. Phylogenetic analyses place it within Chasmosaurini as sister to an unnamed almond formation form in a southern Laramidian lineage, underscoring late Campanian provincialism among horned dinosaurs. Titanoceratops was an enormous horned herbivore, with long brow horns and a broad frill that advertised its bulk and guarded the neck. Its skeleton was collected in 1941 in the San Juan Basin and was interpreted for years as a giant Pentaceratops, until Longrich named it Titanoceratops and suggested affinities with the Triceratops lineage. A 2020 reanalysis instead retained its remains within Pentaceratops, so the name remains contested. If distinct, Titanoceratops would place Triceratopsins on the scene by 74 million years ago. A hefty plant eater, Terminocavus used shearing dental batteries and a sharp beak to process tough vegetation, while its horns and frill likely served in display and deterrence. The holotype, found in 1997 and named in 2020, preserves the back of the frill with an unusually tight midline notch, almost closed, which is the feature behind the genus name. Picture a long-horned chasmosaurine whose rear frill margin reads nearly heart-shaped. Morphometric and phylogenetic work places it between Pentaceratops and Ahshislepelta as part of a transitional sequence. The name Pentaceratops goes back to Carl Wyman's 1930 christening of a crushed skull that Charles Sternberg hauled out in 1921. Most later workers folded Fenestratus into Pentaceratops sternbergii, its odd squamosal, window, and other quirks blamed on distortion, yet a 2020 re-evaluation noted the unusually deep midline embayment and stout parietal bar could tie the specimen more closely to Navajoceratops or Terminocavus, pending better material. In life, think of a broad-skulled horned dinosaur with very long, forward-curving brow horns, a small nasal horn, and an elongated rectangular frill rimmed by large triangular epiossifications, the classic Pentaceratops outline. Functionally, animals of this build were high-throughput browsers. Parrot-like beaks and tightly packed, shearing dental batteries let them slice and pulp tough, fibrous plants, a performance borne out by microwear and CT-based studies of ceratopsid jaws and teeth. Navajoceratops marks a mid-Campanian step in the long-frilled ceratopsian line, known from a partial skull whose parietal bears a deep midline embayment and spindle-shaped episquamosals. The holotype, collected in 2002 at Denver's Blowout, in the Lower Hunter Wash member, plots, by stratigraphy and phylogeny, between Pentaceratops and Ahshislepelta. In life it was a horned, beaked browser with shearing tooth batteries suited to tough plants, and its headgear likely played roles in visual display and intraspecific contests, as seen in other ceratopsids. The skull silhouette is marked by a short, backward-swept nasal crest that rises between the eyes and hooks posteriorly, a distinctive feature used to diagnose Anasazisaurus in its formal redescription. The holotype skull, collected by a Brigham Young University team in 1979 and first figured by Jack Horner, sits at the center of a long-running debate. Some authors keep Anasazisaurus separate, while others fold it into Kritosaurus. Functionally it reads as a high-throughput herbivore, its multi-tissue dental batteries and continuous tooth replacement enabling powerful grinding of fibrous plants with jaw movements that approached mammalian-like chewing performance. Duck-billed Naashoibitosaurus was a saurolophene with a low, forward-peaking nasal arch rather than a hollow head crest, and it likely foraged across the floodplain as a high-bulk browser using powerful, continuously renewing dental batteries. Its partial skull was first interpreted by Horner as Kritosaurus before Hunt and Lucas named Naashoibitosaurus. The name references the Naashoibito interval, though later Basin work revised aspects of that stratigraphic usage. Later reviews disagree on its rank. Some analyses keep Naashoibitosaurus distinct within Critosaurini, others fold it into Kritosaurus, but in either case it represents a large megaherbivore engineered for steady cropping and grinding of tough plants. Barnum Brown named Kritosaurus in 1910 from a partial skull collected near Ojo Alamo, establishing the genus on material from the San Juan Basin. Later redescription depicts a hadrosaurine with a high arched nasal bridge forming a short, tab-like crest above the eyes and clarifies cranial traits that separate it from Gryposaurus. As a large browser, it processed fibrous plants with deep, continuously renewing tooth batteries, an apparatus shown by microwear and histology to create complex shearing and durable grinding surfaces. Long and almost straight, the cranial tube of Parasaurolophus tubucin encloses a maze of paired passages and blind chambers, revealed by CT work on the exceptional. The species itself was coined in 1931 by Carl Wyman from the Uppsala specimen, with the later New Mexico skull refining its diagnosis and showing how elaborate the crest really was. As a Lambeosaurine bulk feeder it used deep, constantly renewing tooth batteries to mill fibrous plants, and that tubular crest likely functioned as a resonator for low, far-carrying calls, ideas tested with acoustic models and CT-based studies. Picture a tall duckbill with a sweeping head tube arcing over the neck, the nasal airway running up into the crest and looping back toward the throat, an especially intricate routing in Parasaurolophus tubucin compared with other species. A towering titanosaurian, Alamosaurus browsed high in inland floodplains, reaching riparian trees and shrubs along broad, low-gradient rivers. Charles Gilmore named the species in 1922 from a nearly complete left scapula and a right ischium collected near Ojo Alamo in San Juan County. Later discoveries in the Naashoibito member include immense vertebrae, one posterior cervical rivaling Pertosaurus, which elevate Alamosaurus to the ranks of the largest dinosaurs known from North America. Texas material adds an articulated neck from a large, mature individual, refining estimates of cervical proportions and overall build. Dermal armor is now documented for the genus via a confidently referred osteoderm from Utah, showing that at least some individuals carried bony skin shields. Picture a high-shouldered, long-necked and long-tailed giant with columnar limbs and a narrow snout, moving between river levees and open flats of an inland floodplain. Aublysodon is now understood as a tooth-based label for tyrannosaurids, keyed to smooth-edged, D-shaped premaxillary crowns, that modern reviews regard as a nomen dubium. Here, a partial skull and skeleton once called Aublysodon mirandus were later shown to be misassigned and clarified with the naming of the deep-snout tyrannosauroid Bistahieversor, capturing the real animal behind those teeth. Imagine a heavy-headed, short-armed hunter working the river levees and oxbows, its robust skull and front D-section teeth built for gripping and tearing, an opportunistic, large-bodied carnivore consistent with tyrannosauroid ecology of the time. Broad, deep-muzzled and heavy-headed, Bistahieversor shows the deep-snout, tyrannosauroid condition in a skull about a meter long, and CT work reveals a brain and sinus system strikingly like later tyrannosaurids, large olfactory bulbs, long cochlear ducts, and voluminous cranial air spaces. Its holotype skull and partial skeleton were found in 1997 by volunteer Paul Seeley and formally named in 2010 by Carr and Williamson, who placed it just outside Tyrannosauridae and diagnosed it with several unique cranial features. Envision a powerful, deep-snout hunter on river floodplain landscapes, roughly 9 meters long and on the order of a few tons, with bony brows above the eyes and a robust, many-toothed jaw built for seizing sizable prey. Stocky-skulled and horned above the eyes, Daspletosaurus was a tyrannosaurian apex predator whose thick facial bones, robust jaws, and serrated teeth suited it to tackling large herbivores. Its secure range is in the middle, especially the Oldman, Dinosaur Park and two Medicine formations of Alberta and Montana. Farther south, early faunal lists once noted an unnamed Daspletosaurus in the lower Kirtland, but subsequent work erected Bistahieversor for the local tyrannosauroid material, rendering Daspletosaurus records here doubtful. Indeed, recent syntheses emphasize that southern Laramidia lacks Daspletosaurus-like tyrannosaurines, while taxa such as Bistahieversor occupy that role. In life, picture a 9-meter biped with a deep head, short two-fingered forelimbs, and prominent lacrimal postorbital bosses, classic tyrannosaurian hardware documented in detailed cranial studies. Applied to the San Juan Basin, that top predator niche is now best attributed to Bistahieversor, with any local Daspletosaurus mentions treated cautiously unless diagnostic skull material says otherwise. Lean-limbed and quick, Saurornitholestes fits the role of a small eudromeosaur that snatched prey with grasping hands, while the enlarged, sickle-clawed second toe helped pin or rake struggling animals. Locally, a nearly complete left frontal led to the naming of Saurornitholestes sullivani in 2015, while an earlier, robustus, frontal from the same unit was later reinterpreted as an indeterminate troodontid, clarifying which small theropod the San Juan Basin material truly represented. In life, think of a lightly built, short-snout carnivore with a long, stiffened tail for balance and relatively large olfactory bulb surfaces, features documented for the genus and especially emphasized in Saurornitholestes sullivani.